Good afternoon. We're going to get started, so if people can please take their seats. We'll try not to have this be, the introductions be longer than the seminar. We'd first like to welcome our EVC, Suresh Subramani.
Yeah, so good afternoon, everyone, and thanks so much for being here. It's wonderful to see a spectrum of people all across academic affairs participate in this, and it shows your level of interest and engagement. And I'm sure we can look forward to a very interesting conversation when Scott talks to us about beyond numbers, how diversity can make us do better and be better at what we do. I also want to thank Linda Green, wherever she... oh, there you are. For our new Vice Chancellor for Equity, Diversity, and Inclusion for sponsoring this symposium, and Jean Ferrante for helping organize this with her team. It's going to be... So, many of you know I'm a biologist, and diversity for a biologist is so critical, ingrained in our thinking about how organisms evolve, how it's important for all aspects of survival and evolutionary outcomes, that when I came into this position as Executive Vice Chancellor and recognized the challenges that we face in diversifying our student, faculty, and staff population, and the challenges that we face and the restrictions with Prop 209 and so on, I took on this as a challenge that really, as an institution, we need to face, because diversity ultimately is beyond equity and inclusion. It is essential for our excellence as a university. As we look forward to the demographics of this region and in the United States and so on, our future workforce here, the students, staff, faculty, is going to be a much more diverse population. And if we don't invest in these individuals and ensure their success, we as a university cannot survive and move forward. So, but in all of this, faculty are driven by quantitative and objective data. And Scott has spent a lifetime trying to collect this data. He's talked all over the country on this, and as you'll hear from him, how public institutions deal with it versus how private institutions deal with it is very different. And so as we look forward to our strategic planning process, timing could not be perfect with Linda's arrival here, and as we go through the strategic planning process, we've identified, I hope with all of your support and enthusiasm, increasing our diversity as a core value that we can move forward. And so it is appropriate for us to be having these conversations. Not all of these conversations are easy, but the whole point is to have the conversations and hear each other out. And from this, I think we can come out with a clearer picture of what is needed, what are the best practices out there, how we can impact this, and ultimately help ourselves become an outstanding institution. So with this in mind, I don't want to belabor the introductions further. I will hand this back to Jean to go on with the rest of the program.
So I'm very pleased that you've joined us today to take part in what is planned to be a series of seminars and conversations around diversity. Shortly, our Vice Chancellor, Linda Green, will be introducing our speaker, followed by his seminar and a brief Q&A. And as you can see, the seminar is being taped and will be available on the web at a later point, and we'll certainly let you know about that. We're doing that for the people who couldn't attend. After the seminar, we'll have a per-table discussion with a set of questions that were motivated by Professor Page's seminar and our current context at UCSD. Each table has a faculty member who will facilitate the discussion. Those are the people that have a little red star on their badge, so hopefully there's one at every table. They're special. And we hope that everyone at the table will participate. We'll work that. After that, we'll be doing that for about 30 minutes, and so we'll be spending about 10 minutes on each question, and then we'll come back for about 15 minutes, and we'll ask you to, one person at each table, to summarize your discussion in 1 minute, so it will be a very quick summary. We will not be taping that part, but we will be having the audio, so just for our own use for future plans and in the Office of EDI. We'll then ask Professor Page for some comments, and then we'll be closing. And we will be following up with you to get some feedback and suggestions for future plans. So without further ado, I will pass it along to our new VC EDI.
See, I think, yes, I even learned how to turn on my mic. Great. Well, of course, Suresh is tireless in his enthusiasm for this kind of work, and this seminar and discussion takes place, of course, because of him. Jean, amazing work, and it's been a pleasure to work with her in planning this. And I always have to say, Ann Briggs in Suresh's office is always a key partner in everything that we do. So thank you so much. I'm really thrilled to welcome Scott Page to the campus. He's a Leonid Hurwitz Collegiate Professor of Complex Systems of Political Science and also Economics at the University of Michigan. He is a master's in mathematics from the University of Wisconsin and his PhD in managerial economics and decision sciences from Northwestern University. He's authored several books, one which is perhaps on the path to be a bestseller, the one that we in part discussed today, The Difference, How the Power of Diversity Creates Better Groups, Firms, Schools, Societies, from which your reading assignment was drawn. I should also point out that he directs the Center for Complex Systems and teaches courses on that challenging subject. And this is very, very fortunate for us. Universities are indeed complex systems according to Professor Page's criteria, which I gleaned from his Great Courses course called Understanding Complexity. We are a population of diverse agents. We are connected with behaviors and actions that are interdependent, and we are able to adapt. That's us. We have brilliant people, all of you sitting here, for example, who are passionately committed to excellence in research, teaching, and service. And we are all here because we care about diversity. How do we nurture and grow our excellence as we become more diverse? How do diversity and excellence intersect? Professor Page is a preeminent thinker on these questions, and we are indeed fortunate to have him with us today. So, thank you.
All right, it's really nice to be here, and it's really flattering to have just such an amazing group of people in the room, many of whom I know. And for me, it's much more fun to come and give a talk to a group like this that's going to be intellectually engaged. As mentioned, I'm not a traditional diversity speaker, and it's really not what I set out to be. I set out to be really sort of a mainstream mathematical economist and mathematical modeler, and I got interested in this field of complex systems. And as I studied complex systems, one thing that became really apparent to me, whether I was looking at an ecosystem or an ecology or a political system, is the functional roles that diversity played. But then when I looked out there at society and how we think about diversity, I found that we were thinking about it really sort of in the wrong way. So I wrote a book called The Difference, which tries to, in some sense, present this to a more popular audience. I was introduced at a public lecture a few months back, and someone said, "This is an airplane book if you're flying to Singapore," which is probably about the best I can do at an airplane book. So what I want to do today is I want to talk a little bit about some context, and I want to focus primarily on really just some logic of how I think diversity is beneficial to what universities do, and how, because the world has fundamentally changed, in sort of this loose metaphorical way in terms of becoming more complex, it's changed in the role diversity plays. So when we think about diversity, a lot of us might initially turn to things like moral philosophy, like here's John Rawls, and think in terms of equity, and think that we have to be fair to everyone based on who they are. There's other people, though, when you think about diversity, they immediately think about the law. And so I'll visit corporations, government agencies, and they're at this place where they're like, they deal with diversity just so they don't get sued. That's literally their sort of fundamental concern. And then there's other people, when they think about diversity, it gets put in this political lens. So on university campuses, when people talk about diversity, oftentimes it's taught within Afro-American studies, sociology, these sorts of things, and it's really framed in terms of social movements and political power. Having trouble reaching my finger. So what I want to do is I want to talk, though, differently. I want to talk about how in today's modern society, in a scientific community like this, that when you think about what it is we have to do, as smart as we are, this sort of like water polo ball on top of our head is only so big, and individually each one of us is only so smart. And when we face these hard problems, that diversity and ability are really sort of equal partners in what we do. So here's what I want to do. I want to start out by just talking a little bit of background about sort of what American society looks like. Then I want to talk about what I call the trade-off logic, which is how a lot of universities think about diversity currently, whether it's in admissions or whether it's faculty hiring. Then I want to give a quick primer on sort of what I mean by the increasing complexity of the world. But then I want to focus on primarily the thing that's in red, this notion of sort of a new logic. Once we sort of think about people solving hard problems, and once we think about diversity in terms of the tools and skills people have, what we see is that we maybe can't just do what I was taught to do in my intro economics classes about ranking people by ability from 0 to 1 and sort of think about only hiring the best people. Instead, what we've got to do is we've got to think about the role that diversity plays. So when we think about what a university does, right, and this is Cardinal Newman, what a university is trying to do in some sense is generate all this knowledge and also create this space where people can become productive citizens in the world. And this is going to be sort of, I think, my end point of this lecture, talk about how incredibly important it is to create an environment where people can learn to interact with people who think differently than they do in order to find better solutions. Okay, so if you look at American society and you look at people above 85 years of age, 85% of them are white. If you look at people under 5 years of age, it's now the case that actually more than half are non-white. So we're dealing with a society that's much more diverse than it was in the past. But yet if you look at where we live and how we live, this is the city of Chicago. Blue dots are African-American people, pink dots are white Caucasian people, and yellow dots are Hispanic people. So this is Chicago, right? This is New York. This is Los Angeles. And then here's the D, my home city, Detroit, right? So you look at these cities, and one thing that pops out at you right away is that even though we're diverse, we're not hanging out with each other. And so people who come from different sort of racial ethnic groups tend to only hang out with those racial ethnic groups. It's also the case that we're incredibly unequal. So if you look at the wealth distribution by race, you'll see the average wealth among white Americans is 110,000. Among Latinos and blacks, it's under 10,000. So when we think about these racial differences and we think about these in these political, moral, legal lenses, we get in this sort of trade-off logic. And the trade-off logic sort of works, someone got to get a clean angle here. Let's try it from here. Okay, the trade-off logic works as follows. They were sort of weighing diversity against excellence. That if we have more diversity, that means less excellence. And this morning I was talking to the college board out on Coronado Island who does the SAT, right? And I spent some time at ETS talking about this. And what we do is we take these kids and we give them scores. So we take something that's multidimensional, right? And we give them an individual score, and then we say, like, you're ranked above this person. And we do this with things like we have SAT scores, right? And we have grade point averages, and we have IQs. But the thing is, people are larger than that. And so what we want to do is we want to sort of have a different way of thinking about things. As long as we continue to think of people in terms of these scores, we're going to have people who think that they're being treated unfairly, that somehow their excellence was sacrificed on the altar of diversity. So this is Barb Gruder, who's one of the people who led the lawsuit against the University of Michigan, right? Basically saying, look, I had higher scores than these other people, therefore I'm more excellent, and therefore I should get into law school and other people shouldn't get into law school. And it was a logic based entirely on thinking in terms of these numbers. Okay. That logic works in 1850. That logic doesn't work in 2012, and here's why. So let me do sort of a very bad version of economic history here. So if you think of the 19th century economy, the early 20th century economy, it consisted of a lot of physical labor. In that world, it's what economists would call additive. So if you have people who are basically mining coal, who are chopping down trees, who are sinking railroad spikes, those sorts of things, are working on assembly lines, and you want to know how much work do I get done totally, well, what you can do is you can just add up the work of those three individuals. So when I was in graduate school at the University of Wisconsin, I worked for a landscaping company in the summer. We would hire people and we'd bring them in and have them work for a couple days, and we basically see how many plants can they plant, how many stumps, we do a lot of stump digging up in Wisconsin in the summertime, how many stumps can they dig in a day? And you hire the people who can dig the most stumps. And the number of stumps dug by your firm is the sum of the number of stumps dug by the people. It's a simple additive economy. And so people have an ability, and you want to hire the people with the best ability. That's how it works. But that's not the world we live in now. So this is a picture by a wonderful book by Ricardo Hausmann called The Economic Atlas of Complexity. And each of these colors is a different sector. You can see what it's represented at the top, and then each is an industry within that sector. And there's a line between the two industries within the sector if they trade or interact with one another. And so if you look at the US economy, or this is the world economy, I'm sorry, if you look at the world economy, you can basically say, okay, this is complex in the formal way we talked about it before. There's diverse entities, they're connected in some way. Those connections are meaningful, they're not just linear connections, they're strong interdependencies, and all these parts are going to adapt. The same is true if you look at the financial system. So this comes from an IMF report. And there was a question of, okay, which banks do we bail out? Which financial institutions do we bail out? If you use linear thinking, what you'd have said is you said, well, let's look at the bigger ones and the smaller ones, and we should bail out the ones that have the most assets. But that's not the logic that they used. The logic that they had to use was to say, look, this is a complex system, and what we care about is if one thing falls, will the whole thing fall? So the numbers you see between these banks represent correlations in the values of their assets with the other banks. And so you see Bank of America, Citigroup, JP Morgan, Bear Stearns, Merrill Lynch, all these huge numbers going to AIG, which basically means when AIG burps, they feel the pain, right? If you look at Lehman Brothers up in the corner, they've only got a few numbers going to them, and they tend to be small, which means if Lehman Brothers fails, nothing happens. And in fact, Lehman Brothers was allowed to fail, and the only thing that happened was Lehman Brothers failed, right? So we don't think of the individual entity anymore. We think of that entity within a system. This is Afghanistan. I get in trouble for putting up the slide because it's private domain and I'm not supposed to, and they yell at me every time I'm putting it up, but I do it anyway. This was done by the PA Consulting Group, and this was done as a budget resource for the US military. And what you see is all the different parts of the situation in Afghanistan. By the way, if you're thinking, why are we in Afghanistan? You might be thinking that even more now after seeing this graph, right? So what they did with this is they basically said, well, if we put money here, and this is the public graph, so you don't see the pluses and minuses, but there are pluses and minuses on the official one. If we put money here, you know, is that going to increase this other thing or decrease this other thing? And they just wanted to make sure they weren't like sort of having money cancel out with one another. Now, the point is, if you look at this thing, no way one person could make sense of this. This is the big point. There's no way that one person could have really fully understand this. Instead, we have to have teams of experts of people each knowing each area, and then have a dialogue between the different parts to try and make sense of what's going to happen in that part of the world. Once we're in that space, once we're in the space of like really smart people like the people in this room sitting around trying to solve really hard problems, it's no longer additive. I can't say, we just hired someone with an IQ of 120, someone with an IQ of 130, and someone with an IQ of 140. We've now got someone with an IQ of 390. That just doesn't work. That is true of the stumps, though. It's still true of the stumps, but the problem is we don't dig stumps anymore, right? We deal with things like Afghanistan. We deal with things like bank bailouts. We deal with things like managing the money supply. In that world, it's not additive. How does that world work? That world works with a lot of people solving things in groups. So this is a picture of Google, right, where they've got little boats in the hallway. It's interesting, when you go to places like Google and Yahoo, you see written on the walls everywhere, like problems people are trying to solve. And sometimes you'll see taped to the wall. Can anyone figure out how to get around this bug, right? Just taped all over the place, right? And the whole idea is you just want all the problems out there so that lots of eyeballs can see it. There's the thing that you'll hear a lot in Silicon Valley, people say, with enough eyeballs, all bugs are shallow, right? With the idea that you just get enough diversity to solve these problems. Now, I'm not against complexity, right? I'm a professor of complex systems. Complexity is good. So if you go back to the Hausmann-Hidalgo book on economic complexity, they run a bunch of simple regressions on things like growth, per capita income, those sorts of things with this measure of economic complexity that they have, which is just, it's the second eigenvalue of an input-output matrix. But what you basically see is the more complex things are, the better they are. But look, the brain is complex, and it's incredibly interesting, right? So things that are complex have this ability to be incredibly productive. So we don't want to get rid of the complexity, but we want to understand it. And the only way we can understand it is in some sense by being diverse. So here's where we've got to change things a little bit then. We've got to move away from this idea of giving numbers to people. Now, this isn't my idea. This is the idea that like anybody who teaches in a psychology department would say. So instead of thinking of someone as having an IQ of 135, we should think of someone as a toolbox of skills. We should think of, here's all the things you've learned. Here's all the mental models you've had chemistry class, you can speak French, you can do calculus, right? You know how to invert a matrix. These are all the things you can do. And so you should think of a person not as a number, but you should think of it as a toolbox. Who does well on an IQ test? Well, someone who's got a lot of tools, someone who knows which tool to apply to a problem, and someone who doesn't make a lot of mistakes. That may not be someone who necessarily is very creative, right? Because sometimes creative people make mistakes, and sometimes they apply the wrong problem to the tools, right? But it's a particular type of person that's going to do well. So when we think about tools, when psychologists think about tools, they think about things like this. They think about perspectives. How do you represent the problem? So if you go to, there's a website called the Polymath Project, which is set up by these mathematicians to have groups of mathematicians solve problems. On this website, they have this thing about like how do mathematicians solve problems, right? What do they do? And one of the first things they have is using different perspectives. And this is what's so funny to me. So if you go to almost any corporation, any government agency, any university, even a lot of preschools, they'll have on their webpage, we value diversity because it brings diverse perspectives. And most people read that and they want to put their finger down their throat and barf. No, because like, it just seems so politically correct and trite, right? But yet, then when you go to the Polymath, when you go like, the world's best mathematician, this is Timothy Gower, right? Probably like the second or third best living mathematician. He's got on his website, how do mathematicians solve problems? Diverse perspectives. That's rule one. So one of the things we want to talk about is why this isn't just metaphor, it actually matters. Psychologists talk about categories, engineers talk about having heuristics, social scientists talk about having different models, people in the humanities talk a lot about experiences and narratives. This is literally what we mean by tools. So when you think about hiring, or think about admissions, you can think about, okay, here's a set of people and here's a set of tools. Now if you look at this, Martha has the most tools, right? She's got 4. But if you look carefully, Luis is the only person who has tool 1 and tool 3. So Michigan had a civil rights initiative authored by the same person that wrote the California Civil Rights Initiative. And we had to go back and think about how do we do graduate admissions. And so we went back and looked and found all sorts of things. One of the things we found, so the graduate school, I unfortunately said we should do this and so ended up having to share it, which is always a dangerous thing to do. Never say we should do this at a public university, it'll get you. But we found that there were a lot of threshold effects. So there were cases where like, you just couldn't get a PhD in math if you didn't score above a certain level on the subject test. You couldn't get a PhD in sociology if you didn't score above a certain level. But after those threshold effects, we didn't see much correlation. But one thing we saw is cohort effects. We saw, like, for example, in some of our social science departments, if we didn't have someone in the entering class who had tool 1, which might be really good knowledge of statistics, or we didn't have someone who had tool 3, which had lived in an urban area. So if you have an intro group of sociology grad students and they all grew up in the suburbs, that's just not going to work, right? The discussions just aren't going to work. Just like if you have a whole bunch of, just really eager political science grad students and none of them took any stats as an undergraduate, it's not going to work, right? So what you want to think about is, do we have, as an ensemble, the collection of tools that will make us do well? So when you look at a group of people, yes, you see identities and backgrounds and those sorts of things, but what you really want to think about is, what sets of tools do they have that are going to enable us collectively to solve these problems? So when people think about diversity, they typically think in these sorts of things. So there's diversity web pages that talk about, we're seeking out diversity. They talk about race, gender, sexual orientation, culture, ethnicity, those sorts of things. When I'm talking about diversity, I'm talking about these perspectives, heuristics, those sorts of things. Now these are related. They're not divorced, but they're also not the same thing, right? And one of the really interesting challenges, and this is not a space I'm in, is to think about how these do relate empirically, right? And it's something that cultural anthropologists, psychologists, and all sorts of people study. Let me show you an example. This is work by Jeffrey Johnson, who was at South Carolina, and then he was head of a social science division at the US Army Office of Research. And he decided to study this indigenous group of people known as people from St. Louis. So this is a set of cultural artifacts from this group of people called people from St. Louis. And one of the techniques that cultural anthropologists use is something called a pile sort, where you give these people this list of artifacts and you say, put them in piles where things that are like each other are similar. So I'll make fun of myself here. If I were to put these things in piles, I would put all the green leafy things in one, all the fresh meat and fish in the other, and all the sort of Michael Pollan, middle of the supermarket stuff in cans that I'm not supposed to eat in a third pile, right? And my cultural group, which is a bourgeois bohemian, right, would put these exactly like this. I didn't grow up a bourgeois bohemian. I grew up in a rural area of Michigan, and I would have sorted them like this growing up. I'd have had like anything that I understood as a vegetable here, anything as meat and fish here, and then weird stuff that I'd never heard of, like over here. Fennel, arugula, sea bass, those would have been very foreign things. So why did Jeffrey do this? The reason Jeffrey did this, and this is what's so interesting, is suppose you want to ask people how much money they make. Well, Valerie, Joel, your economists, if you ask them, they're going to lie. It's just a fact, right? I mean, they're not going to tell the truth. But if you ask people to do a pile sort, they don't even know how to lie because it's how they see the world. And so what's really fascinating about these two graphs, it turns out if you're wealthy, because you could do this with control groups for new the income, the two salmon end up in different categories. And if you're poor, the two salmon end up in the same category. So if you want to know someone's social class, you could ask them, you'd probably get it wrong, or you could ask them about salmon, and you'd probably get it right. But what's important here is who we are affects how we see the world, right? And then how we see the world is going to affect how well we can solve problems. Let me give one more. This is sort of my favorite example that I learned when I was had a roommate from a different racial group. Where you store your ketchup. How many people store their ketchup in the fridge? How many store it in the cupboard? No cupboard. So if you're a cupboard, you can probably get back to England fairly quickly, right? Somehow, through an answer. Yeah. So you used to store when you lived in England. There you go, right? And so what's funny about this, if you do, my friend Jim Fowler isn't here, but if you did testing, you'd actually find a gene then for ketchup in the fridge. No, because like anybody who's British, would have the more British genes, and they wouldn't store the ketchup in the fridge; they'd store it in the cupboard. And those of us that aren't of British descent, we wouldn't have that gene, and so we would store it in the fridge. Uh-oh, we've lost everything here. You got it? Uh-oh. Let's see. It's all coming back. There we go. All right. Let's see. So why does this matter? Why does this ketchup in the fridge stuff matter? Because what we want to talk about is how these different ways we see the world improve our ability to solve problems. But here's where it gets sort of fun for me, because what I do, actually it's not unlike what the two Joels here who are from the econ department do, is I like to just write down very simple models to help me make sense of stuff, right? So I don't write down models to try and empirically test them. I just try and write down models so that I can try and make sense of how things work. So I don't have a horse in this race. I don't have a political agenda. I'm just trying to figure out what role does diversity play. Sometimes it's good, sometimes it's bad, right? So I'm not going to come out and say, well, all diversity is good all the time. We're going to see some stuff here where it works, some stuff where it doesn't. So sort of what I'm saying here is 2 heads are better than 1 in a lot of cases. But here's the tricky part. Someone can also say, too many cooks spoil the broth. Someone can say, a stick in time saves 9. Somebody can say, he who hesitates is lost. So there's a great website called Opposite Proverbs, where they have all these things back to back. And this, last year I taught one of these Coursera courses. I taught it in the spring, and then I taught it again this fall. So I had 60,000 people in the spring and 100,000 people this fall. And it's called Model Thinking, and I talk about why models are important. And I begin the class by talking about these opposite proverbs. And I say, look, we can't do science, we can't run policy, we can't run our lives just by sort of throwing out some mantra like 2 heads are better than 1, or too many cooks spoil the broth, or he who hesitates. The reason we have science and the reason we write down models is to figure out, when is it the case that 2 heads are better than 1? When is it the case that too many cooks spoil the broth? When is he who hesitates lost? When does the stick in time saves 9, right? Most of the scientific knowledge, some would probably say all of the scientific knowledge we have, is conditional in some sense. Economists would say it's conditional on the state of the world. Other people might use different terminology, but the point is it's conditional. So if I want to say 2 heads are better than 1, I better have some math, right, that says when 2 heads are better than 1. Okay, so let's do this, and let's start out with prediction. So prediction has gotten a lot of play recently because Nate Silver wrote this book, The Signal of Noise, which really was a bestseller, right? And it's a really interesting book, and he talks a lot about things we can predict and things we can't predict. And one of the things he says is that we're probably not that good at predicting things that are complex like the economy. So for example, this isn't his graph, but this is one that I use all the time. Here's economist forecast, which is in gray, and the real economy, which is red. And you'll see is that economists, like my tribe, is really good at predicting what's going to happen when nothing changes. We're not so good when things change. But, we're not terrible either, right? What's interesting about prediction, though, maybe not. Wow. There we go. Okay. So a friend of mine, Jim Surowiecki, wrote this book called The Wisdom of Crowds. In this book, he tells a whole bunch of stories. Now, Jim's got a PhD in American culture from Yale. And what he did, this is an exercise in selection bias. What he did is he went and looked at all the cases where crowds were smart, sort of amazingly smart. And he said, what's going on here? And what he said is going on is they're diverse. That seems to be the thing that's driving it. But this is a very qualitative sort of understanding. It's lots of case studies. And all these case studies, he said, either people had different incentives, they came from different backgrounds, they'd had different experiences, right? Something was going on to make the crowd diverse, and that's why they got things right. So he gives a ton of examples. One of the examples he gives is the 1906 West of England Fat Stock and Poultry Exhibition. This is due to Francis Galton. 787 people guessed the weight of a steer. They guessed 1,197 pounds on average. The steer weighs 1,198 pounds. So they're within a pound. Somebody recreated this at a TED Talk, actually, I think it was in San Diego last year, and the crowd was within 2 pounds. So we can learn from this, well, if we ever have to guess the weight of a steer, get a crowd. But that's not of much scientific value, right? So neither is this thing. So you can think about, how do you guess the weight of a steer? Well, if you go on the internet and you say, like, how do you guess the weight of a steer? There's nothing there. But if you look up, how do you guess the surface area of a sphere? It turns out this is something that people have studied. And there's a wonderful book called The Spherical Cow. And it's about the importance of having simple models. And basically, here's the trope. If you want to know how much leather you can get from a cow, you go to your calculus book and you look in the back for the double integral of cow, and it's not there, right? You can find arcsecant, everything else, but cow is not there. So what you've got to do is you've got to approximate the cow. And so what you can do is you can imagine a spherical cow. And if you imagine a spherical cow, maybe about a meter around, then you make some estimate based on that, right? And that's fine. And that seems really good, and that's done by an engineer. But for me, this is offensive, because I'm from the state of Michigan, and our governor created Gateway. And so I would make a gateway cow, right? I mean, it's literally in the water now in Michigan. There's gateway boxes everywhere. So if I made a gateway cow, I would get a different estimate than somebody made a spherical cow, because I wouldn't have pi in my estimate, right? But somebody made a spherical cow would have pi in their estimate. Why does that matter? It matters because you can write down a theorem called I call it the diversity prediction theorem. When I wrote my book on this, it was really hard because Liu Hong and I sort of derived this, and it was really simple to derive. We said, somebody must have figured this out, and we turned out, in fact, I think 4 people got tenure for this, which is good. It's a good theorem. It's pre-internet. No, I mean, so someone in forecasting and statistics, somebody in forecasting in marketing, someone in statistics, someone in computer science, someone in math, all about the same time in the 70s, derived this thing for different purposes, and obviously they weren't reading across different journals. But it basically says this: the crowd's error equals the average error of the people in the crowd minus their diversity. And this isn't as tricky as it seems. So the crowd, that's C. Theta is the truth. So it's the crowd minus the truth squared. So that's how far the crowd is off. SI is each person's prediction. So SI minus the truth, you're just summing up over all the people how far off they are. And then the last term, a statistician might call variance, but it's realized variance. So it's actually the diversity in the predictions. Now you can write a more sophisticated version of this called the bias variance decomposition theorem, and the diversity term will be captured by negative correlation. But what's important here is if you have a group of people making a prediction, what matters is having them be pretty smart and also having them make different predictions. Now what's the logic here? If 2 of us make predictions and we're both off by 6, but we make the same prediction, then the crowd is off by 6. But if we're both off by 6, right, and Gene's 6 above and I'm 6 below, then our errors cancel. So holding the average error the same, if we're more diverse, if one of us does a sphere, one of us does a box, we'll collectively do better. Okay, so if you go to Galton steer, the crowd was off by less than a pound. Average error is 29.56. These are squared errors, so that's about right? You can guess the weight of a steer within about 57 pounds. When I left Caltech to go to, my wife got a job at Iowa, I went to Iowa. There's not much to do, so we bought a farm. And then after I bought the farm, I found out I had to buy cattle, because if I didn't keep the grass down, I'd be like violating the law. So I found myself a cattle rancher, which wasn't a plan. So I went to these cattle auctions where there's really good pie. But you also have to decide, like, you know, which cattle you're going to buy. And it turns out you can guess the weight of a steer within about 50, 100 pounds. It's not that hard. So the important thing here is these people weren't some sort of like cattle weight guessing savants from the west of England, right? I mean, they're no different. I mean, a couple hours of training, a little bit of pie, you guys could all be pretty much as good as they are, right? But they happen to be diverse. Now, it's a funny thing, like, why were they diverse? They were probably diverse because they probably knew the approximate weight of their own steers. And so if you take a basic psychology course, they'll talk about anchoring and adjustment and these sorts of things. And so that sort of experiential diversity probably related to the diversity that we see. Okay. I get emails all the time, because I taught this course with 150,000 people in it, and also because I have talks on this, where people will say to me, Scott, I took that formula and took data from our organization or our firm or our 7th grade science class where we guess the number of jelly beans in a jar, and you're going to be so surprised to learn that it held there as well. The equation held. And so I'll send them like this picture with the right, this is the Pythagorean theorem, like graphically proven, and I'll say, check this out. Hope you're sitting down. Here's a right triangle, 5, 12, 13. 5 squared, 12 squared, 13 squared. Oh my God, it works again, right? The point is, it's just a mathematical fact, right? When you're combining a bunch of predictions, that the two things you want are ability and diversity. Now, ideally, you'd have enough ability that people would get it right, and then you don't have any diversity. Everybody gets it right. But this is where the complexity part comes in. Once the problem becomes incredibly hard and really high dimensional with lots of interactive terms, no one's going to get it right. So what you want is you want people to be getting it wrong in different ways. Because if they get it wrong in different ways, collectively, they'll be better. Okay. Maybe. All right. So this is guessing the weight of steers. Let's play for real. Let's do something that's actually more meaningful. Netflix, maybe I should just have somebody advancing back there, because this is, when I go like this, advances that. Okay, so in 2006, Reed Hastings, who's the CEO of Netflix, had a contest. We said, if somebody can do better at predicting which movies people like than we can, by 10%, we'll give them $1 million. So the way this works, if you have Netflix, if you go in there and you type in something like Avatar, I have 2 boys who are 11 and 13. So if I type in Avatar, it doesn't say Avatar's a 5-star movie. It just says, for me, it'll be a 5-star movie. If I type in Rush Hour 3, it says 1 star. If any sentient being types in Rush Hour 3, it'll say 1 star. Okay, go ahead. So here's how this worked. There were 6 years of data, 500,000 users, 18,000 movies. The data is, standard sort of training set, testing set. The testing data was a probe thing where you can go and see if your model worked, then a quiz for these final contests, and then they kept some back for the final test to see who the ultimate winner would be. So here's what people did. This was really fun because this was a chance for all these people who do machine learning and prediction to compete against one another to see who's sort of like the best in the world at doing this. Initially, there was a lot of really strange sort of hairball sort of approaches, but eventually everybody settled down to a common approach based on, ironically, just like those tile sorts, categories. So each team was representing movies by these vectors. So initially, the vectors were things like, is it a drama? Is Morgan Freeman in the movie? Because it turned out that mattered, right? Do people die? Do people kiss? Is there a car chase, right? Is there an alien? These would all be properties of a movie. Eventually, it included things like, how many weeks did it stay in the theaters? How many weeks before it went on video from being in the theaters? How much money did it make? Other sorts of signals. Each person is then represented by a vector, and you basically just say, like, if you like car chases, and the movie that has car chases in it, you're going to like the movie. And then you correct for the movie and for the person. After the first year, the leader in this was Bellcore. Now, this is a misspelling of Bellcore, but this is the old Bell Labs. And a guy named Robert Bell was leading the team, Berkeley PhD in statistics, brilliant guy. Their model had 50 dimensions to it. So for every movie, all 18,000 movies, they had 50 dimensions for each one. But because this is a fairly complicated nonlinear fit, they had 107 different models, some of them using different combinations of the 50 variables. Their best model could beat it by 6.8%. But when they combined their models, when they took their best models with other models that weren't as good, they could get to 8.4%, right? This is the diversity prediction theorem in action, right? A whole bunch of models that are diverse are better than the best model. Okay. So after a year and a half, they're still leading, but they're not at 10%. And so his boss comes into him and says, okay, first off, let me genuflect to you. You are the best predictive person in the world. Congratulations. But you also have this thing called a job, and maybe you should go back to your job. And so Dr. Bell said, well, fine, I'll just win this thing then. And his boss was incredulous because it's been a year and a half and he hasn't won it yet. And he's like, how are you going to win it? And he says, I'm going to win it by calling people not as smart as me. So if we go next, what he did was he called the team in second place. Said, look, we all know I'm better than you. We've got 2 years of data. We also know that you're different from me, and so if we merge, we'll do better. So they merged, but they didn't get the 10%. Then they looked at the team in third place, and they're basically doing the same thing as the team in second place, same with the team in fourth place. Team in fifth place, this strange Canadian team, is doing something different, which was a team called Big Chaos. So they merged with them, and then the three of them, when they added some things that Big Chaos had that were really nice. Their best models are not 8.4%, but when they merged all their models in a fairly sophisticated way, they got to 10%. So now you've seen this diversity prediction theorem logic twice, right? Basically, the best and the brightest couldn't get there, so we brought in people who we know demonstrably weren't as good, and then they get there. So they get to the 10.1%, they win the $1 million, but not quite, because it turns out the contest rules say once somebody gets to 10%, it ends in 30 days. And the reason for that is they were afraid somebody from UCSD or Illinois or Caltech or Berkeley or something would beat them in the first hour. And in fact, somebody beat them by 5% within 2 days, right? But now it's been 2 years, and this is sort of ridiculous because they got to wait 30 more days. So when Dr. Bell was giving a talk about this at Michigan, I was talking to him. I said, what was your reaction, when you found out there were 30 days? And he said, our reaction was, oh, shit. And the reason their reaction was, oh, shit, if you go to the next slide, is here they came. There's 23 other teams who are not as smart, right? They're not even close. You can look at the leaderboard. They're not even close. But they're wickedly diverse. Right? Like there's probably a German team that is classifying as how much Schadenfreude there is in the movie and stuff like that, right? They've all got different vectors. So this group called the Ensemble merges all these models. And if you go to the next slide, then what you got is at the end, the Ensemble beat Belcore with like a day to go. And in the end, this is the root mean square error. Belcore beat them on the 5th decimal point and got the $1 million. But it turned out the contest only went to 4 decimal points. And so it's who submitted first, and Belcore luckily submitted 22 minutes earlier, so they got the money, which they gave to New Jersey Public Schools. But what's interesting here is we see now for the third time, right, this sort of logic of bringing in people who don't look as good on paper, have the lower SAT score, right, on exactly the same problem, who allow you collectively to do better because you're tapping into their diversity. If we go one more, here's sort of the final bonus quiz. So let me go back to that one more second. I guess I don't have this slide on here. What was really great when the Ensemble, because there's a lot of grad students, they were very snarky. So when this thing ends, they have this up there on their webpage, and they say, Belcore takes second. And the reason Belcore takes second is you've got 2 models that are diverse, so what's better? Averaging them. If you average the 2 models, you get these each one by 10.1%, you get a 10.2% improvement if you average the 2 models. So again, you see it one more time. Okay, so let's go on. Let's go back to Surowiecki's book. So he writes this book, The Wisdom of Crowds. Go again, one more. And you want to write this book, and you look at only cases where crowds are really wise. So that means selection bias. You're only going to take cases where the crowd error is really small, right? So next slide. If it's going to make a book called The Wisdom of Crowds, it's got to be a really hard predictive task. So it can't be how many eggs were in a dozen or something like that, right? It can't be, oh my gosh, the crowd got it right yet again. So if it's got to be a really hard problem, that means it's going to be a problem where the average error is really hard. Go one more slide. If you've got a problem where the average error is really high and the crowd error is small, since this is an identity, it's got to be the case that diversity is big. So the reason that Surowiecki found diversity in all these cases is because he had to, as a nature of the exercise he was doing, right? He was looking for places with small crowd error, hard problem. The only way you can get small crowd error, hard problem, is if you've got diversity, okay? All right. So let's go forward. This also plays out, just to give 2 other examples. These 2 people called the Roamers, who you may have heard of, who used to be running the US economy, they're no longer, they're back at Berkeley. For fun, did this experiment. They look at just sort of doing a wisdom of crowd approach of the staff forecast versus the open market committee's forecast. And you see the nice positive numbers in front of just the average of the staff forecast. And you see small negative numbers in front of the FOMC forecast. Again, you see the same thing. The crowd is better than Bernanke or Greenspan. Okay, and then one more, just to show you how this plays out. In this book, The Signal of the Noise, there's a lot of great examples in here. My personal favorite, though, is this. If you look at weather forecasting, which we've gotten much better at, right? These computer models they have are unbelievably sophisticated. But here's what's so cool. There's also all these people who've been studying weather for a long time and looking at these models. So after the computer model pushes out everything it can push out, kind of really smart, creative people look at the maps and say, I think it's more likely to rain. And in doing so, they improve the precipitation forecast by 25% and the temperature forecast by 10%. Why? Well, because they've got a different perspective, right? They're literally they're looking at a spherical cow or something. They're looking at something different. They see patterns that even these incredibly sophisticated 5,000 variable computer weather models somehow miss, right? So again, we're seeing this sort of incredible value of, there's no way that people are as smart as these computer simulations, right? Because computer simulations are way better than human forecasters ever were in the past. But they must, and he comes to the same conclusion I do in looking at this. Nate says, they're just seeing something different, right? But that something different is adding value, all right. But it's not clear if the computer programs could vote, I don't think they'd hire the humans. Because they'd say, look, your test scores are just too low, right? But the point is, because they're seeing something different, they add value. All right, so let's go forward again. That's prediction. Let's go to something else. Let's go to problem solving. And go ahead. So when I was teaching at Caltech, my first job, I was teaching intro econ. I was using John Taylor's book, and it was talking about people like making washing machines, I think. And I'm explaining this to the undergrads. And they were like, Professor Page, this may be like good for economic history, but this is not, we're not going to do this. So I think, is Serge Belanger still here? Is he on faculty here? Yeah, so Serge was in the class, right? And people like Serge are saying, we're going to go like work at UCSD and solve problems. We're not going to like be digging out stumps, right? And so I said, hey, look, it's a metaphor. Like, working on the assembly line is just a metaphor. People have human capital, which we represent by this vector, and people have high human capital or low human capital, and you want to hire high human capital people, and the value of the firm depends on the human capital of the people. So you want to have higher ability people. People have abilities between 0 and 1. The more ability you hire, the better you do. So I constructed a model where I said, okay, there's a bunch of agents that I had a really hard problem, a high dimensional problem. It was a traveling salesperson problem. And I had people have different perspectives. So they encoded this in different ways. And they had different heuristics, different tricks they had. And there's nice books on heuristics for the traveling salesperson problem, so I had them like using different heuristics. I ranked these people by their performance. So all these agents are smart, right? So none of them are just doing random stuff. They're all pretty smart. And then go ahead. And then what I did is I created a team, a firm, one of which took the 20 best that I'd created. Another one just took 20 random ones. Okay, and if we go ahead again, what I was expecting then was I was creating this sort of alpha group of people who did really well on the problem, and then sort of a random diverse group, some of whom did well and some of whom didn't. Okay, so then what happened? This is what was kind of a bummer. The diverse group did better. But this was on a traveling salesperson problem. So then I did this one that was Euclidean search. I did something on a graph. It was sort of like a green eggs and ham thing. I did it on a plane, on a tree, on a graph. No matter what, the diverse group kept always doing better, and we couldn't figure out what was going on. And eventually, I wrote a paper. I brought in my friend Lu Hong, and she and I wrote a paper saying the diverse group almost always outperforms the group of the best and does so by a substantial margin if, right, this is going to be conditional on some assumptions, right, because this isn't always true. And it turned out that when I was setting up these models, I was making some implicit assumptions that made this true. This is the notion of conditional knowledge. Let's talk about what those are. So go ahead to the next slide. So what was happening is this, is these people had a finite set of tools in their heads, right? So these were ways they had of solving the problem. Some of those were better than others. And so when I took the best people, they tended to always have the same tools. So think of this in the context of, so in 2008, I went to the IMF and talked about this stuff. And when I go to the IMF, it's this really relaxing experience for me because it's all my people, right? We all have the same tools. We all like, say, heteroscedasticity and fist bump and stuff like that, right? No, so we all, so everybody has tool A, which is like a PhD in economics. Everybody has tool B, which is lots of mathematics. Everybody has tool C, which is just like love of looking at lots of data. Everybody has, a lot of people have tool D, which is an understanding of political systems. Some people, not me, have tool E, which is a knowledge of like economic history and things like that, right? But if you're in the room, here's all these people that individually are really good at understanding like the world's financial system. But you've got 600 of them who are all kind of the same. In fact, most of them went to 4 schools. Who would be the diverse group here? Well, the diverse group here, the IL person might be someone like my colleague Lada Adamek, who studies the robustness of networks, who's a physicist. Would you want her managing the world's money supply? No. No, because like physicists want to be within a factor of 10. So that's just too much of an error bar, I think, for Obama. But the thing is, would you want to replace one of the 600 cookie-cutter economists with someone who's spent her life really thinking about how networks work? And the answer is probably yes, right? Because the value add would be big enough. The EZ person might be someone who studied social psychology. Would you want a social psychologist making decisions about where to invest in international securities? On her own, probably no. But would you want to replace the 599th economist with one of those people? Probably yes, right? So if we go ahead and you look at sort of, if you do the math, can you go ahead? Oops, we lost our slide person. There he is, he's back. If you do the math on this, here were the implicit assumptions I was making, and you can make different ones, but here's the implicit assumptions I was making. So the first one is what we call the calculus condition. Now the reason we call this the calculus condition is from biology, you can think about there being a fitness landscape. So just like a payoff function if you're an economist. What we in effect were assuming in terms of people having these heuristics was that people could take derivatives. So wherever they were on the landscape, they could climb to a peak, right? The second condition was you have to be drawing from a diverse set of people. If it's the case that you say there's only 5 tools total in the population and everybody has 3 or 4, you're going to get the team of the best does better. But if there's hundreds and hundreds of tools and everybody only has 6 or 7, then you're going to get the diverse team does better. And then the last one, which is most important, this is the thing that really drove it, for easy problems, the group of the best did best because they always solved it. But as the problem gets harder and harder and harder, the group of the best does worse and worse and worse relative to the diverse group. And Jonathan Bender and I have been working on some very even simpler models than this to try and show the logic as to why that pans out. Okay, so if we go ahead, let's look at some data on this, just because this is something that it should play out empirically. Okay, so go ahead, keep moving. Here's one of my favorite recent studies. So this is the Ravens Progressive Matrices test, and this is the gold standard of IQ test. Now, what makes an IQ test good, this is kind of ironic, is if it predicts how well you do on IQ tests. If that sounds circular, it should, because it is. And this is the best one at predicting how well you do. And it does really well, of course, at predicting itself. So if we go ahead a slide, at Microsoft, where they used to give people quizzes, they still do a little bit in terms of who they hire and then hire the people who score highest on those quizzes, they thought, well, I wonder if that makes sense. So they got a bunch of data, and these are Microsoft Research Labs, on British schoolboys who took this Ravens Progressive Matrices test. And what you see is their individual IQ scores on this axis, and then they have their contextual IQ on the other axis. Contextual IQ is higher if you get questions right that other people got wrong. And what you find is for a fixed IQ, there's massive contextual IQ. And this holds up if you have a control set of questions, another set of questions. Contextual IQ holds up. So there's something, there really is something there. Now for Microsoft, this is interesting. If you're a labor economist, this is interesting because most professions draw from a thin slice of the IQ distribution. So you can look up in textbooks in terms of different professions what IQs they have. Physicists, don't worry, you're right at the top. Physicists are right by bus drivers. No, so physicists are right at the top. And, but within those fixed IQs, there's massive differences in contextual IQ, which is really interesting. Okay, go ahead, one more. So that's sort of micro. You also see things at the macro level. So this is every paper published in computer science, average number of authors, 1980 to 2005. You see it goes from 1.6 to 3.0. Why? Well, presumably, there's some value in having more co-authors, right? Go ahead, another one. If you look at medicine, it's even more pronounced. Can you go ahead, one more slide? If you look at medicine, it's more pronounced. It went from 1.5 in 1950 to almost 5 now. Okay, go ahead again. Can you go ahead again? Okay. The reason why, and this is Ben Jones has been working in this space. He's an economist at Kellogg at Northwestern. If you look at the, let's use 100 citations as a cutoff for like a home run paper. If you look at papers in science and engineering or in the social sciences, team-written papers are 4.5 times more likely to be home runs than solo-authored papers. It's also the case that in most disciplines, even in the top journal, the median number of citations for a single-authored paper is 0. The median number of citations for a team-authored paper is not, and that's because one person is really capable of having a bad idea. I've had many myself. Teams of 4 aren't as likely to sign on to that. But again, you see this big advantage, so that's why things have gone. Okay, so let's go one more. Let's unpack this even deeper. This is some wonderful work by Melissa Schilling. This is just within the social sciences. They wanted to say, okay, what makes a paper have high impact? And so you can look at years since PhD. This is the odds ratio. So 1.14 means you got a 14% higher chance of having a high impact paper. Prior cites doubles it. So if your stuff gets cited more, you're twice as likely to get things. Author count actually lowers it, which is interesting because you think more papers, isn't that more diversity? Shouldn't that have an effect? Turns out on its own it doesn't. And the reason why is the two things that matter the most are depth. This HHI is, if you're an economist, it's the Herfindahl Index. If you're a political scientist, it's the effective number of parties. If you're a biologist, it's called Simpson's Index. This is just sort of a weighted measure of the number of disciplines you're citing. So the more different sort of distinct disciplines you cite, the higher your odds ratio. But then what's most interesting is atypical connections, has an odds ratio of 15. So if there's papers in there that should not have been cited, right? They just don't make any sense given the rest of the citations. It has a massive increase in how often the paper is, how likely the paper is to be high impact. Okay, so let's go ahead again. This is work by Lada Adamako, I mentioned before, who's the network theorist, who has unfortunately left me for Facebook. Hopefully she's going to give money to my center, I can hope. She looked at all US patents and every single natural science paper in JSTOR. And this is, again, these things are sort of hard to increase, but this is the likelihood that a paper has this is just number of citations, both for patents and papers. Proximity is a measure of how similar the authors were to one another in terms of their research. And what you see is massive negative numbers on both proximity for the natural science papers and for the US patents. What's particularly interesting about this paper is Lada, in reading my work, she's like, well, we should be able to test this. And so she did a test on, are scientists better off being deep or diverse? Right? Individual scientists. And what she found is there's a slight advantage to being deep, right? To doing one thing and doing it really, really well. And she's like, ha, you're wrong. And I'm like, well, what if we look at teams of scientists? And then it turns out, right, we see incredibly strong evidence. What you want is deep people interacting who do different stuff interacting together. And that's where the big one is. And then one more. This is some stuff by Brian Uzi, Ben Jones again. It even works at the level of university. So this is this is an impact advantage on papers. And these are sort of school pairings. So if you have two people, this is social sciences and science and engineering. If you have two people from tier 1 schools interact, just being from different schools has a huge impact factor on the likelihood of the paper having a big impact. Again, the explanation that they come up with is that it has to do with sort of diversity. Okay, one more. Other stuff that's even more speculative, that's just kind of, I think, interesting to think about is there's these scaling laws about worker productivity as a function of population size. So if you look at how productive workers are in San Diego or New York compared to Ann Arbor or a smaller town, people seem to be more productive in bigger cities, even if you account for everything you can possibly account for. This goes back to work by John Quigley in the 70s and 80s. It's more recently been done by Jeff West at the Santa Fe Institute. And the story that and actually Ed Glazer in his book, The Triumph of Cities, talks about this a lot. His book that came out a couple years ago, right? That people in cities are just more productive. And the story is that they're just bumping into more ideas. And by bumping into more ideas, they're better at what they do. Okay. So let me finish up here by talking about the following. When we think about these advantages from bumping into people who think about the world differently, they've been trained differently, that have different life experiences, those sorts of things, it requires creating a culture where this is allowed. And one of the things I think that's most, and not only allowed, but it's encouraged. One of the things that's most troubling, I think, when you look at this literature is how small biases aggregate. So one of sort of the people that I've looked up to the most as an intellectual mentor was this guy named Thomas Schelling, who's a Nobel Prize winner, was at Harvard, actually at Maryland, but wrote this book called Micromotives and Macro Behavior. And it's just about how things add up. And it's really interesting in terms of how things add up, especially in this space, and how biases accumulate. Okay, so if we go ahead, the slide. So one thing you can do, and this is just a crude regression that I did with John Vandermeer, who's a biologist at Michigan. We look at the Gini coefficient of different countries, and we just downloaded the IMF innovation data, where they rank each country by innovativeness. And what you see is the less equal a society is, the less innovative it is, just at sort of a broad organizing principle. What's interesting, though, when you think about why inclusiveness might matter and how this stuff adds up in such an interesting way, this is a paper that just sent shockwaves to U of M. I don't have the same effect here, but in 2012, Corinne Moss-Rakusin wrote this paper where she took the exact same vita and changed the name and sent it for postdoctoral positions in the natural sciences, right? And you see the competence ratings, hireability ratings, and mentoring ratings for the male and the female student. And if we go ahead again, if you look at the salary offers, if we go ahead a slide. There we go. On the salary offers, we're also higher for the men. Go ahead one more. This is for you. It's your former boss, John. This is John Wiley, who was the president of the University of Wisconsin-Madison. This is his last day. He wasn't always this happy, but it's your last day. It's because you're really happy. And he and I were talking about this, I don't know, 5, 6 years ago. And we get to think, we're trying to think through what's the logic of why these small biases make such an effect. And if we go ahead, he was a physicist by training. The logic is this. If you take 10% off the edge of a line, you lose 10% of the line. If you take 10% off the edge of a square, you lose 19% of the square. And if you take 10% off each edge of a cube, you're down to 73% of the cube. So if you go ahead one, if you think about making it requiring, let's just say 10 steps, and if each of those 10 steps, there's just this slight 10% bias, then instead of having 100 women or 100 people from a disadvantaged group at the top of those steps, you're only going to have 35. And so because the academies, especially this way, but it's also true within the corporate sector, getting somewhere isn't just going from A to B. It's usually A1, A2, A3, A4, A5, A6, A7, A8, and then you get to B. Those little biases, right, add up in a very big way. Okay, if we go one more, a couple years back, I was down here in San Diego at this totally fascinating event called the Black Board of Directors Association, right? So it's two things I'll never be, black and on the board of directors of a major company. Obvious reasons for both, I think. And Robert Johnson was there, who owns BET, and he was amazing because he gets up and he says, when you get on the board of directors of one of these companies, the first thing you've got to do is you've got to say you can't hire based on the size of the ad in the yellow pages. You can't hire based on, we're talking about hiring firms, right? You can't basically go to some place based on their size or their market share, because if you do, you perpetuate inequality. And I'm sitting there totally stunned. And the reason I'm totally stunned, if we go ahead a slide, is in my model thinking course, in my class with like the 150,000 students, and in the class I teach at Michigan on this, I teach that exact same model, but not in that context. I teach it in the context of city formation. So there's a famous model of city formation where it basically says, what are the odds that you move to a city? Let's suppose it's proportional to the population. So the odds that you move to New York, which is 10,000 times the size of Munising, Michigan, is 10,000 times the probability you move to Munising. So the probability you move somewhere is proportional to its size. The same is true with making internet connections. If the probability you link to a site is proportional to the number of people linked there, then what's going to happen is that's going to create a distribution. So if you go ahead, that distribution is going to be a power law distribution, which means that this is the size and this is the probability. So instead of getting a bell curve, if what people do is move to cities as a function of their size, or link to web pages as a function of size, or hire firms as a function of their size, what you're going to get is you're going to get a handful of really, really big things, and then lots of really, really small things. And in fact, if you look at the distribution of firm sizes in the United States, what is it? It's power law that looks pretty much just like the city size distribution. So let's go ahead, just to give you some perspective on this. Suppose I said heights were distributed by a power law, and fix it so the average height is 5/9 and get the variance as close as I can. Okay, so if we go ahead, one more slide, that would give me 10,000 giraffes, right? Which would be lousy. Architects would have a heck of a time, right? Go ahead again. You'd also get 170 million people 7 inches tall, which you'd have to watch out that you don't step on them. The reason this is so pernicious, though, let's go back to why Robert Johnson was so smart. If we think about let's hire people from this school, or let's hire this firm, or let's do this based on reputation, if we do things based proportional on reputation, and you aggregate that up, what you get is you get a power law distribution in terms of reputation, firm size, income distribution, firm distribution, links on the internet, right? Those sorts of things. This isn't what we want. We don't want a world with 170 million people 7 inches tall, right? We want to have things be smoother. Okay, let's go ahead one more. So here's the hard part. This gets to the, remember that I was talking about the opposite proverb. So a stiction time saves 9. So I've given you a bunch of cases where, this is computer science speak for stiction time saves 9. I've given you a bunch of cases where 2 heads are better than 1. What about too many cooks spoil the broth? That's also true. Let's think about cooking. What's true of cooking? It's irreversible. So This was just a few months ago. I do most of the cooking in the family, and my wife was making minestrone, and she said, I'm making minestrone, it's not very good. So I tasted it, and it wasn't very good, and the reason why is there was no bacon. So I fried up some bacon and put it in there, then I added some more chicken stock, and then it was pretty good. And then the doorbell rang, and our vegan friend Patty was coming over for dinner. So I didn't have any anti-chicken stock I could then put in the soup, right? And so it's the irreversible nature. So there's a reason they say too many cooks spoil the broth, is because there's a sense in which cooking is an irreversible process. Nobody says too many engineers spoil the house, because you can pound the nail back out, right? This stiction time saves 9 thing, I put this up because I think what's so interesting about this diversity stuff to me, and one thing that's been really a great experience for me in terms of going out and talking to different places, is that American society, by some estimates, spends, if you go ahead one more slide, $9 billion a year on diversity training and education, writ large. If you take government, private sector, universities, schools, huge amounts. We were talking about this at lunch. Caterpillar Corporation, which I've spent some time with over the last couple months, because it's been so fascinating to me. They're in Peoria, Illinois. They used to be, sort of pardon my French, but a bunch of white people from Iowa and Illinois who sold tractors to a bunch of white people from Iowa and Illinois. Now they're in 100 and some countries. And now they have to deal with training their employees to not only be able to sort of deal with people different from them, but actually to want to, right? To want to understand them, right? To want to work. So because society is so much more interconnected, it's incredibly important that universities create this space where people can learn that. So one of my friends who works in the education field, Uma Jayakumar, who's at USF, talks about the educational experience at a place like UCSD or at Michigan Riot as a place where people sort of build diversity human capital, right? You build this ability to work with people different from yourselves, that then when you go out, that we don't have to spend $9 million trying to train you out of it later. Okay. So let me show you a really interesting experiment with regard to this. Go one more. For some reason, not popping up. One more. So Catherine Phillips, who's a good friend of mine, was at Northwestern, now at Columbia, she decided to do this experiment where she knew the answer. So what she did is she had people read a whodunit. And then she put together people who all thought the same person did it versus groups of people who were diverse. And then she said, okay, how accurate are the groups? Well, this slide someone got screwed up, but the diverse groups were obviously more accurate than the homogeneous groups because we've got the theorem. So in prediction, you know that's going to happen. But the reason she did this experiment is because she's an organizational theorist. And she then asked the people, how effective is your group? And she then even let them bet on if they thought their groups were right, which instead of calling effectiveness, she calls confidence. And people in the homogeneous groups bet more. And the reason why is if you're in a homogeneous group, people seem really smart. Because basically you're all thinking the same thing, which is what you're thinking, which is probably the right thing. If you're in the diverse group, right, then if the diverse group is going to be better than you were yourself, then they have to disagree with you sometimes, by definition. That has to be true. But that's a really hard thing to accept. So when I was at Michigan, I guess my second or third year there, I got put on the university or the college level tenure committee. So after you make it out of the department, the college decides, was this an inside job? Should this person really get it? And we overturn some close votes. It's an incredibly diverse group of people in terms of departmental diversity. And I would sometimes come home from these meetings where we had somehow voted somebody off the island who I thought was really great, or we'd kept somebody on the island who I thought was like not so great, right? And I would be incredibly mad, right? Because I mean, the university is important to me, and I'd just be furious. And my wife would say to me, she'd open up my book to this page, right? And then she'd say, unless you took a smart pill or something, right? Unless something really amazing happened today when you got smarter than everybody else in the committee, the only way the committee is better than you, the only reason they have the committee and not just all-knowing you making the decision is because sometimes the committee is going to disagree with you, and most of the time when the committee disagrees with you, they're probably going to be, hate to say it, right? And so, but when you do these experiments, we often don't, this is an experiment so that people got to see and feel that they didn't do as well in the homogeneous group, but most of the time we don't get to see and feel that. And this is why it's the hard part. It's just really fun to co-author with people who went to the same grad school as we do, who make the same assumptions and that sort of stuff. But if you look at it, your impact factor is not going to be as high. It's really fun to hire people who had the same advisor as us. We can talk about all the funny things that Leo Hurwitz did and stuff like that, right? That's all great. But the reality is, right, we do better if we bring in people who are different. So let's go one more. One more. Keep going. It seems to be giving the same slide. Keep going. So one thing then, let me just sort of end with this. There's a ton of research on homogeneous versus diverse groups, whether it's cognitive diversity, whether it's identity diversity. And what's interesting about it is how empirically this plays out. So let me explain it in terms of what I call the parable of the bike. If I went out in the parking lot and had a bunch of, let's take 5-year-olds, and had them run as far as they could in 10 seconds, I'd get a mean of 50 meters, and I'd get a pretty tight distribution, right? Mostly between 40 and 60. Put those same kids on a bike, right? Then I'm going to get some people, the mean will be about 50. I'll get some people who go a long ways, and then I'll get like carnage over here, right? Of kids wipe out. Go ahead a slide. If you look at homogeneous and diverse groups, the first time they interact, the data looks about the same. The means are about the same. And this is hundreds and hundreds of studies. But no one disputes, so therefore, because the means are close, people dispute the mean like crazy, right? Different surveys dispute. But what no one disputes is the very best groups tend to be diverse, right? So when you get the cases of the really exceptional performing group, it's almost always diverse. And we've seen the logic as to why that's true. But it's also the case that the very worst groups are diverse. And the reason why that's true is because people lack this sort of diversity human capital in terms of getting along with people different from themselves. They don't validate people. They don't listen to one another. So you don't have this culture where that takes place. If you look over time, what's interesting is the mean gets a little bit better, at least in my reading of the literature, for the diverse groups. But most groups sort of just improve, sort of slowly improve. Some groups completely go into the carnage camp, right? Because they don't learn how to make things move. Okay, so let's go ahead. So one of the questions then, and this is Daryl Smith, who's a local person who's at Claremont. She talks a lot about the need to restructure our university. So if you think of the amount of, if you wrote down a dollar value for how much UCSD has changed the number of people they hire, design of buildings, job classifications, to deal with the information revolution, you'd get a number probably in the hundreds of millions of dollars, right? If not more. If you ask how much they've spent to deal with the fact that the student population and the population of the state has changed from being all white to being very mixed, you'd find that they have spent a very small percentage of that, right? So in the one case, we've completely restructured our universities. In the other case, we haven't. Okay, and then last slide. And I think the real challenge then is this, and this is the thing that we struggle with at Michigan all the time, is how do we change our university in such a way to sort of exploit this? So Phil Hanlon, who's a brilliant man, who's our provost, who is just leaving now to go become president at Dartmouth, he and I've talked a lot about this because if you think about hiring faculty, we're going to be training people who are going to go out and probably have 12 to 15 jobs over the course of their lives, have to work in a really diverse workplace, and have to sort of interact with all sorts of people different from themselves. And then yet we're training faculty, and we prize faculty who sort of often like to just sit in their office safe with their books, protecting them from anybody different from them, and dig really, really deep. Now, as a lot of Dominick's work shows, that's actually really useful. You want these people who go deep, but we also need the people who are connecting those people who go deep. So I think there's this really interesting tension when you think about how do we best leverage diversity. So the point is not all diversity, all the time, diversity is good, there's no such thing as ability. To the contrary. The point is, as problems become more diverse, right, as problems become more complex, more adaptive, more parts, more interdependent, harder to make sense of, you need lots of sets of eyeballs, you need lots of heads. So you're going to need people from different disciplines interacting with one another, working together, and so you need that diversity. So it's not just ability anymore. It might have been just ability 50 years ago. It was definitely just ability probably 100 years ago, but it's not true now. And so the question is, how do we make universities work? How do we rethink things so that we can leverage those differences to do better at what we do? All right, thank you very, very much.
Probably have time for a couple of quick questions. Scott?
Hi, thank you. It was very interesting. I'm Katerina from Mediterranean. I'm an evolutionary anthropologist. So very similar to our EBC, your point makes very good sense.
Right.
Diversity is a constant foundation of any type of group for it to survive. I can add many examples to your argument.
Right.
From the hominid fossil record, there are hominids that got over-specialized and got extinct. They got very, very good at one particular thing with very little diversity, and they got extinct. So we know from biological evolution, from Darwinian theory, that diversity is very, very important. There is no argument about that. I would be very interested in hearing a little more about how do we actually make it happen in the most advantageous kind of way, so that the mix of the traits that you are describing can give us real advantage. From biological evolution, we know that it depends on what kind of traits we talk, at what point in time, what mix, and then how do we decide about those and who decides?
Right.
Thank
Oh,
you.
yeah. Somebody have an easy question? No, so on your first point, yeah, I was at Genentech a while back, and it's fascinating because there I used Fisher's fundamental theorem, right, which from ecology, which basically says the rate at which a species adapts is proportional to the phenotypic variation, right? So the rate at which you adapt is just relates to diversity in a direct way. And what's interesting is you have a group of like 500 scientists who all think, oh my gosh, this is a diversity seminar, this is going to be non-scientific, and then you sort of say, wait, how do you think about the world? And you realize that, in fact, when they think about the very nature of the problems they solve, diversity lies at the core of how these nature's found these amazing solutions. What they did, I think each organization and each department is going to have to think about how do we make this really work and where is the biggest immediate value add. I think you should always look for low fruit. A dear friend of mine, Michael Cohen, who just recently passed away, used to talk about digging for fruit because it's so low. At Genentech, what was very low was this, is they realized that when problems got really hard and really important, people closed ranks because they didn't want to see weakness. They didn't want to show any weakness to other employees. And so what they decided to do is, on people's, they have a thing called key performance evaluations or something like that. On their evaluations, one question was, what was the most important decision you made for Genentech's bottom line last year? It was the most important decision. And then the question below it was, who from outside your silo did you invite to help you solve that? Basically, handcuffing people, forcing people to leave their silo. Depending on, I've been to other organizations where, there's a lot of sort of status hierarchy, and they've done stuff where, they've used like just basic Delphi method things from the RAND Corporation, where when you get to the meeting, you've got to bring what you think on a piece of paper, and those get randomly handed out, and then people just read whatever they were given to separate the person from their ideas. So that you're basically creating a culture where everybody's ideas get read. I think that you have to look in a very serious way about what your organization is doing, what your department's doing, and then ask, where do we think the biggest value add is? I mean, there's no way I can come in as an outside person. I was at a meeting of CEOs in DC a couple of weeks back, and the head of a major corporation said, how can I use this to make $50 million? And I said, that'll be $49 million. I mean, if I knew, I'd be selling it, right? I mean, the point is, you can't. I mean, there's no way. I mean, what I can do is lay out some general principles and get you to say, I'm going to stop thinking about, I mean, obviously you still want to think about all the, legal, moral, and political reasons why this is an important set of issues. But as a scientist, you want to put on your science hat and say, there's a lot of reasons why diversity is really useful in evolutionary systems. There's a lot of reasons why diversity is really useful in engineering systems for robustness. And then think about, do any of those models, or even at the metaphorical level, are there ways I can apply that same logic here to make me better at what I do?
Okay, one more quick question.
Back here. Right.
Multi-author essays. And one of the things that I know really troubles both editors and library science folks who are invested in Black studies is the extent to which many of the citation indexes don't include the core journals in the field of African American studies. Right. And so what that means is there are situations in which one could have a diversity in terms of number of authors, but not the kind of diversity, but going alongside with the exclusion of African American studies. It could suggest more broadly that you could have what you're calling cognitive diversity without identity diversity, or that UCSD could incorporate a significant amount of cognitive diversity and still not look like the state of California, which indicates that you can't really bracket the political questions or the ethical questions.
So no, you're absolutely, you can't. There's a limit as to how much. I'm not saying we want to bracket these things necessarily. I think that but I think the thing is, what I'm trying to do is say, I think when you go to most universities or you go to most corporations or you go to most government agencies and you say diversity, it immediately gets put in those other boxes, right? It doesn't get put in this sort of, can it make it better at what we do? And so that's the space I'm trying to occupy. In terms of the particular thing you mentioned, I mean, it's absolutely the case that what journals count, I think there's massive sort of, path dependency and sort of history, or hysteresis, whatever you want to call it, in terms of what journals really matter and which ones don't. And you see this, the same is true like in computer science. I've been at meetings with computer scientists and people in Afro-Am who sing the same song. Because in computer science, it's all proceedings, right? It's, because they don't even have journals. And there's places that won't count that. And so, in fact, Lu Hong and I, when we wrote the paper in the Proceedings of the National Academy of Sciences, I had to write a letter to her dean saying, no, this is a real publication. I'm not kidding, right? No, because it said proceedings. It didn't say journal. If it said Journal of the National Academy of Sciences, it would have really counted, right? I mean, then the next day it was like on their webpage, right? But the point is that it's, I think you're absolutely right that I think that when you think, you could get cognitive diversity, you could get a substantial amount of cognitive diversity and not necessarily be, reflective in a numerical sense. Now there's, Heather Gerken used to be at Harvard, now at Yale Law School, talks a lot about this reflectiveness is an interesting thing, right? Because I think that if everything reflected society perfectly, then you don't have diversity at the population level. And then you're also saying that some groups of people are always forced being in the minority, right? In every single interaction, they're going to be in the minority. And that doesn't seem like that's the right thing to do either. I think the question is, do you have sufficient numbers and the correct, sort of, or an appropriate culture in each place where people feel validated and safe and they feel like they're being welcomed and they're allowed to contribute? Because one of the things, and there used to be, I think, in a very sort of naive way, a bunch of sort of threshold literature, like you need exactly 27% of this group before they contribute. It really varies by place, right? I mean, and it varies by, so you can be in a place where you feel safe, where in the larger community, there's enough people who belong to your particular, racial, ethnic group, whatever it is, gender group. And then if you happen to be in a meeting where you're the only one from that group, you still feel safe. You still feel like you can contribute. But there's other organizations where that's just not true, right? I mean, where people feel so threatened on identity grounds that you need to literally keep a threshold of every single number. So, I mean, this is outside my pay grade, right? I mean, I'm not trained or haven't thought deeply enough about how one thinks about these notions of sort of reflection versus threshold. I think it's a really interesting thing, for a community to have a dialogue about. But I feel fairly strongly that there certainly are sort of critical mass. There's a lot of evidence in terms of critical mass sort of things, right, that play out in all sorts of, sort of incredibly interesting ways. Just like, if you're the only African American in a 200-person physics class, the professor knows if you're there every day or not, right? Whereas they don't know about the other person, about another person. So there's all sorts of things where these numbers matter, right? But I think that's something that, as a community, you've got to figure out how do we balance these things out. But let me end sort of with this point. I'm a social scientist, and I think that the diversity of experiences, when I think of those first graphs I put up, I mean, to make sense of this world, to craft effective policies, to think about how our world should work, which is what universities are supposed to be doing in their social science departments. I don't know how you could do that without a faculty and a set of graduate students and a set of students that aren't broadly representative of the societies in which they live, right? And I say that as someone who grew up in an all-white part of Michigan with a bunch of private schools that everybody went to high school with that are sort of really nice, all-white, Christian Reformed schools. And I think the visions of the world that come out of that sort of experience are not going to be the visions of the world that are going to help us deal with the sort of society that we have now, right? And in fact, those same people who work at Caterpillar, right, are sort of overwhelmed if they had to be in a room like this. Okay, thank you.
Okay, we'll now move to our discussion section. We'll have about 20 minutes, so we'll end on time.